Hello everyone. I will tell you about climate adaptation on the industrial area Euvelgunne. My name is Joerie Olthof and I study built environment at the Hanse University of Applied Sciences. Currently, I'm in my final year. My research is conducted for the Department of Spatial Adaptation and Water of Noorderruimte. The project that I worked on aims at making Euvelgunne climate adaptive, as the area undergoes water-related problems in the case of heavy rainfall. This project's main focus is reducing flooding and turn the area into a sponge that absorbs rainwater. It is a showcase project to spread the information and possibilities, as other industrial areas often encounter the same problems. To get this all done, an extensive area will be disconnected from the sewage system. This will mean that a large amount of rainwater will either be stored on site or redirected to the Hunzeloop, a former river that is being restored to a thriving natural area. My part in the project is monitoring water collection tanks at 2 companies. This is done with small CTD divers that measure water pressure, temperature, and conductivity. The main aim is the water quantity, to see how the tanks are functioning, especially the water level after a drier period. BMN Bouwmaterialen, the first company, has an enormous area of impermeable ground, as they supply building materials and store a lot on site. Most of the rainwater that falls on the property will now end up in the Hunzeloop through a new pipe, especially for rainwater. A part of the roof is connected to the new water collection system. BMN installed 3 tanks with each a capacity of 4,000 liters. Rainwater from the roof gets into the filter box on the upper image. Here, the rough pollutants will settle and the water will flow into the tanks. In the case of heavy rainfall and filled tanks, the surplus of water will flow into the new drainage system towards the Hunzeloop. The collected water is used for flushing the toilets. It is extracted from the tanks and pumped to the toilets. With the CTD divers, I monitored the tanks. The graphs you see here are the rough data that is gathered. To get insight into the water levels, also rainwater data of the municipality is used. After plotting the graph of the water level and rainfall together, a clearer image is created. The rain fills up the tanks. After using the toilets, the water level drops again. In the middle of the graph is a dry period without fluctuations in the water level. This can mean the tanks are empty, or there is a large buffer in the tanks that can't be extracted by the pump. Further tests are required to find out. Elmer, the second company, is a health science company with a laboratory. Their main building will be connected to the water collection system. The rest of the property is drained to the Hunzeloop. 4 underground concrete water tanks, with each a capacity of 10,000 liters, are installed. On top is the car parking. The tanks collect the rainwater that falls on the main building. Elmer uses the water for 2 freeze dryers and their toilets. The water will first be pumped out of the underground tanks, and after filtration, it's ready to use. The data of the water tanks look a little similar to the ones at BMN. Further research will be done about the water usage. Thank you for your attention.